Hello, my name is Dr. Rowell, and I'll be guiding you through this introduction to correlation and regression from a descriptive statistics perspective. This video is produced by the StatPAL project, and it is to be completed prior to your coming to class. A brief quiz will be given to measure your comprehension of the material. After you finish participating in this video, you should have the big picture of linear correlation and simple linear regression. You should be able to use your TI-8384 calculator to generate a regression equation for a given set of data, and you should be able to interpret the results associated with the regression equation. This understanding will help you get the most out of the in-class activity about this topic. Please note, we are not going to learn how to use formulas in this lesson. So we'll begin with the big picture concepts of correlation and regression. And you'll learn in terms of correlation first. We will learn about positive correlation, negative correlation, and the correlation coefficient. For regression, we'll look at the slope, the y-intercept, and the coefficient of determination. The first topic for today is correlation. In simple terms, it is a measure of association between two quantitative variables. The direction of association can be visualized using a graph. The association can be either positive or negative. A positive correlation would be a case where as the x values increase, so do the y values of the data. For example, in the summer, as the temperature increases, so does someone's thirst. For negative correlation, as the x variable increases, the corresponding y values decrease. So, for example, as the price of an item increases, the corresponding number of items sold could decrease. Next, you'll be asked to complete a little quiz showing which scatter plot shows the positive correlation. We will use Pearson's sample correlation coefficient to measure the strength and the direction of the linear association between two quantitative paired variables. We're going to use little r to represent Pearson's sample correlation coefficient. The strength of the linear association ranges from r values of -1 to +1. And the closer r is to 1 in magnitude, the stronger the linear association. If r equals 0, then there is no linear relationship. Other than the ones shown on this chart, there are no other values of r which have exact, precise meanings. The top left picture shows an example of perfectly linear positive correlation. And the bottom left has no correlation. It's created where it has a little r value equal to basically 0. But most of the time in the real world, neither of these situations happen. Instead, you might have something that's r equal 0.8275. So the chart shown here gives some possible interpretations for different values of r. However, keep in mind that in different fields, such as perhaps medicine and psychology, used in some other sciences, the values of r could have different interpretations. In this chart, all the values in the table are positive, thus the associations are in the positive direction. but the same strength interpretations hold for negative values of r, and only the direction interpretation changes. In some fields, we might say if r equals 0.9, then that's a strong association. 0.5 might represent a moderate association, and 0.25 a weak association. The pictures show an example on the top left of a strong positive linear association or correlation, and on the bottom right a moderate negative correlation. Next we will take a quiz to see if you can determine the scatter plot, which corresponds to a data set with r equals negative 0.98. Now we move to our second topic, regression. Regression is a statistical method for finding the line of best fit for one response dependent quantitative variable based on one or more explanatory independent variables. When we find the line of best fit, we want to estimate the data with a straight line, which has the smallest amount of error. We will define what is meant by the smallest amount of error at a later time. Right now, we will look at an example and see how to do this on your calculator. For our example, consider that you are planning an outdoor party in the summertime, and you might need to estimate how many soft drinks to buy. In your planning, you will of course need to know how many people are attending the party. However, as you determine the number of soft drinks for each person, you might also want to consider how hot it is. The temperature has been forecasted to be around 95 degrees on the day of your outdoor party. Now, in real life, we realize that you would probably just make an estimate based on some of your previous experience and make a logical increase based on the temperature. However, we will use some hypothetical data to determine how thirsty people might be. We call this the temperature water data. And we will use regression to find an equation which represents this relationship. So, we want to look at the following steps for reaching a solution to our problem. First, we'll draw a scatter plot of the data to help us visually consider the strength of the linear relationship. If the relationship appears relatively strong, then the correlation coefficient can be used as a numerical verification. From there, we could use simple linear regression to find the line of best fit. Our next step is to learn how to use the TI-83 or 84 calculator for correlation and regression. Then we will interpret the results in the context of the problem. The steps listed on this slide are what we will do to visualize the data and to find the regression line using the TI-83. The first step will be to turn on the calculator diagnostics. Then we'll learn how to enter the data, draw a picture of it, call that a scatter plot, find the equation of the regression line and the correlation coefficient, and graph the regression line with the scatter plot. So the preliminary step is to turn the calculator's diagnostics on. To do that, press second of 0 for the catalog, and then scroll down to diagnostics on. The marker points to the right of the words. As you can see on the screenshot here, you want a little marker to point to diagnostic on. Then press enter, and press enter again. And when you do, the word done should appear on the right-hand side of the screen. If it did not, clear your screen completely, your home screen, and start these instructions again. Now we need to enter the data into the calculator. Here's the hypothetical data that we collected from the temperature water consumption example. We'll go over the steps and then give you a chance to enter the data into the calculator. So the first step is on your calculator, find the stat key. Then go to Edit, E for Edit, E for Enter, and select number 1. Now you can enter the X values in the list, number 1, and that list, number 1, is named L1. We will put the Y values in list 2, which is named L2. Pause the video if you need additional time to enter the data. After you put the data in the list, then we'll go back to the home screen. If for some reason you need to clear a list, move your cursor to the name L1, for example, and then press Clear and Enter. Now let's put the data on the screen so that you can enter the data in your calculator. Once again, press the Stat key, and then with your cursor on Edit, go down to number 1, which is Edit as well. Okay, I'm going to put the data on the screen now. And you can see the data and you can put it in your calculator. If you need to pause the video, please do so that you can get all of the data entered in the calculator. Now in this case, we're going to enter the temperature to be the X value and put that in list 1. And the water consumption will be our Y value, and we'll put that in list 2. Let's see if that makes sense. We're saying that the amount of water that is consumed depends on the temperature outside. Pause the video if you need extra time to enter the data, but once you've entered it, make sure that you check that your data are lined up correctly and there are no typos. This data is called paired data, and the 75 and the 16 belong together, for example. They must be on the same row. On the day when the temperature was 75, the person drank 16 ounces of water. Now we would like to visualize the data by setting up a scatter plot. Press second of Y equals, which is the stat plot key. Y equals is on the top row of your calculator. When you go to the stat plot menu, select number 1 for plot 1 and hit enter. Then use your arrow keys to move the cursor down to on and hit enter. Arrow down to the type of graph and select the first graph under type. Under the X list, enter L1, which remember is second of 1. And under the Y list, enter L2, which is second of 2. For the mark, you can choose any mark you want. I picked the biggest one because it's easier to see. Now we want to view the scatter plot, and to see it in the best view, we can press second of mode to quit and return to the home screen. And then we can press the zoom, which is on the top row of keys, and go down to number 9, which is zoom stat. The scatter plot will then be graphed and will be in the best viewing window for that particular data. Please check to see which scatter plot matches your graph that you got. If you have not entered the data in your graph, in your calculator, this is the perfect opportunity to go back and do so now. There'll be additional questions to check and see if you're getting the answers correct along the way. Next, we want to find the regression line. We go back to our favorite key, which is the stat key. And then we go over to the calc menu. And we go down all the way to number 8, which is the linear regression of a plus bx. And I do realize that we are passing number 4, which is linear regression of ax plus b. They both give the same result, just in a slightly different format. You need to tell the calculator where the x's are, and they're in list 1, so you press second of 1 to get list 1, L1. And then I put a comma, and the comma key is right above the 7. So then you'll put second of 2, and that'll give you list 2. And so your end result would be linear regression, list 1, comma, list 2. That says linear regression on my x's, which are in list 1, and my y's, which are in list 2. There are other commands you can use to get your graphs, your equations stored, etc., but this will be enough for us. Then press enter, and when you do, you should get some different values. And so now please put in the value that you got to 1 decimal place for B. The results that appear on your screen should have been in the form y equals a plus bx, where a is the y-intercept and b is the slope. If you correctly turned your diagnostics on, you will also have the correlation coefficient, r, and a value for r squared, which is just little r squared. This value for r squared is called the coefficient of determination. Notice that the TI-83 shows r squared as r2. Pause the video and write down your equation. You can round to 1 decimal place. Next, we want to graph the equation, and so we're going to press the y equals key, which is on the top row of the calculator, and enter the equation under y1. Please clear out all other equations. Then press graph, and the line will be graphed approximating the data with a straight line. If you have any trouble getting the regression line and the values for r and r squared, then please pause the video and go back to the beginning of the calculator steps and work through them slowly using the words on the PowerPoint slides. Next, we want to interpret the results in the context of the problem. So the graphing calculator gave us the equation of y hat equals negative 96.9 plus 1.5x. When you see a y with a caret over it, the little up arrow is called the caret, it is read as y hat. Y hat gives us the predicted value of y for a given x value. If we use the variable names, the equation is water consumption equals negative 96.9 plus 1.5 times the temperature. We will want to be able to interpret the slope and the y-intercept of this equation in the context of the problem. So the slope, you should remember back from algebra in high school. And you can think of it just as perhaps your algebra teacher taught you, which was rise over run. So rise is the vertical change, or the change in y, and run is the horizontal change, or the change in x. If we put the units in, then we see that the slope is the change in water consumption, the y, per unit change in the temperature. Our slope is 1.5 ounces per degree Fahrenheit. That means that for each 1 degree you increase the temperature, you expect an average increase of 1.5 ounces of water to be consumed. The y-intercept is the value of y when x equals 0. So in our example, the y-intercept is the amount of water consumed, y, when the temperature, x, is 0. Our temperature units are degrees Fahrenheit. Well, we cannot expect this model to be accurate at such low temperature ranges. because our data was collected in the summer with temperature ranges from 75 to 99 degrees Fahrenheit. So the model only predicts the temperatures in approximately that range. So our model is not applicable for x equals 0. To solve the problem of predicting the amount of water a person would drink when the temperature is 95 degrees, we can simply substitute the value of x equals 95 degrees Fahrenheit into the regression equation y hat equals negative 96.9 plus 1.5 times x, and solve that for y, water consumption. So if x is 95, then we get out the result of 45.6 ounces. Note that 95 degrees is in the range of values that were used to find the regression equation, so we can use this equation to predict the water consumption when the temperature is 95 degrees. If the desired prediction had been for 50 degrees, then the model should not be used, since the value of x equals 50 does not fall in the range of the predictability for this model. Now we're ready to take a short quiz where you predict the amount of water a person would drink when the temperature is 90 degrees Fahrenheit. A different way to measure the strength of an association is little r squared, where little r is the sample correlation coefficient that we saw before. When we have little r squared, it's called the coefficient of determination, and the general interpretation is that the coefficient of determination tells the percent of the variation in the response variable that is explained or determined by the model and the explanatory variable. So in our example, r squared is about 93%. Thus, almost 93% of the variability in the amount of water consumed is explained by the outside temperature using this model. Note, this means that approximately 7% of the variation in the water consumption is not explained by temperature. So perhaps there's another variable that accounts for the remaining portion of variation. Can you think of a reasonable variable? Multiple regression is the name of the method that would include one or more independent variables to predict the amount of water people would drink. An example could be the activity that was being done outside. If you're mowing the lawn, you could be a lot thirstier than if you were laying in a hammock when the temperature was the same on those two situations. This is the time to pause the video and write down any questions that you have at this point for your teacher. You can bring those questions with you to class and ask at the right time. So you should go over your notes about these important topics before coming to class. Make sure you know about correlation, simple linear regression, how to use your calculator to get results, how to interpret the results in the context of the problem, in particular the slope, the y-intercept, little r, which is the correlation coefficient, and little r squared, the coefficient of determination. Next, you will take a brief quiz to practice on your own.